Alright, today we're continuing with differentials. We're going to be doing problems where we approximate the height of f of 1.9 given some graph, and we don't even know what the function value is, but we can use the tangent line to approximate what the height is. But before we can do that, I want to go to this picture and get a formula that we're going to be using. So I'm going to derive this formula for you. What I'm going to say about this is that the change in y we determined the other day, given 2 points on this function. This one f or x comma f of x, and this one is, because I'm going along the x-axis here, if I travel along further, it'd be x plus change of x comma, then the function value would be whatever value I would get when I plugged in the x plus change of x. So we denote that as f of x plus change of x. So change in y is those two y values subtracted from each other. So f of x plus change of x minus f of x. What we learned in the previous day is that we learned that change in y and dy are approximately equal to each other. So I now can say that dy is approximately f of x plus change of x minus f of x. Remember, my ultimate goal is to find or approximate this new height. So what I'm going to do is I'm going to get this f of x plus change of x by itself. I'm going to do that by adding f of x to both sides. That gives me a new equation of f of x plus change of x is approximately f of x plus dy. Since I don't have any values for dy, what I'm going to do is I'm going to replace dy. Dy, we found out the other day, is equal to f prime of x dx. So the last thing I'm going to do to this equation, which will be the formula I'm going to be using, is I'm going to say that f of x plus change of x is approximately f of x plus f prime of x dx. What I'm going to do is I'm going to copy that onto this page and show you how we're going to use it then. I've got f of x plus change in x, which is approximately equal to f of x plus f prime of x dx. What we're going to be trying to do is find what the function value is at 1.9. I can't see that from the graph. I can't come up with the answer, so what I'm going to use is the tangent line to the curve. I'm going to approximate it using this formula. Well, the one piece of information I know is that it does go through the point 2, 1. So I'm going to use 2 as my x. My change in x, the difference between 2 and 1.9, is negative 0.1. So I'm going to plug 2 in for my x. And my change of x is negative 0.1, which is also going to be my dx. So 2 plus negative 0.1 is 1.9, and that's the height I want to find the function to be at. F of 2 I get from the graph. F of 2 is 1. Plus the derivative of 2 is the slope of the tangent line to the curve, which is down 1 over 1. So that means that f of 1.9 is approximately 1 plus 0.1. That gives me the approximate height to be 1.1.